So here we have the different generations of wheel bearings, and here on the monitor on the top left is a tapered roller bearing.
So, that is this one here, right?
Exactly. This kind of bearing is used on the front axle of my classic car, but also on the non-driven axles of modern cars.
Okay.
Picture this. There are always two bearings arranged in mirror position. They have to be lubricated, sealed, and then adjusted during installation. These two bearings are now integrated into one unit, and that is why the first generation is the development of the tapered roller bearing.
Yeah.
This bearing is pre-lubricated, sealed, and can be adjusted by tightening, which increases the torque. Another variation of the first generation unit is a bearing with balls. And you can see that this tiny contact surface means minimal resistance.
Let me guess. So this depends on the demands I make on the bearing. Here I'm carrying more weight, and here I have a lower rolling resistance, right?
Right.
Okay.
Additionally, starting from the first generation, it's possible to integrate a magnetic encoder into the sealing ring.
What's that?
The magnetic encoder provides a rotational speed signal, or wheel rotation reading, for ABS, ESP, or ASR system, among others. And with the second generation bearings, installation becomes even easier. The bearing already contains a flange to connect it to the brake disc and the wheel, or the bearing is connected directly to the stub axle. Here's something special. The 2.1 generation bearing has a retainer that holds the bearing in an axle position in the knuckle. This replaces the Circlip that's used in conventional bearings. In addition, bearing play is adjusted during production by means of a process called orbital forming.
That means less work for the mechanic.
Yeah, sure. It's quicker, so the job's done faster.
But here we have a flange on each side, right?
Yes, but that's the third generation bearing.
I see.
One flange is fixed to the knuckle and the other is attached to the brake disc and the wheel.
So I can save even more time during fitment.
That's correct.
And what's the cable for?
That's the connector for the integrated ABS sensor that provides the rotational speed signal for ABS, ESP, ESR, and so on.
Okay, good.
Here's another special design featuring a patented face spline.
How does it work?
I actually set up a model.
Oh, Ralph, you'd lose your head if it weren't screwed on. Is this what you're looking for?
Thanks, you're too good to me. The face spline transfers the power via the drive shaft to the wheel bearing, enabling a 50% increase in torque in the same sized design.
Wow, that's a lot.
Here we are looking at an LFT seal,
Which stands for?
low friction torque.
Says it all.
It does just that.
So it rotates easier.
It rotates a lot easier. It's shown in that working model over there. Try it yourself by spinning both wheels at the same time with your hands.
Oh yeah.
You see, the LFT seal runs for much longer, less resistance, and more efficient.
Okay, I understand that. But let's go back to the wheel bearings. So we can't really say that the first two generations are completely outdated.
Not at all. For each new car model, we develop a wheel bearing that is the best solution for the demands of the manufacturer. It doesn't matter if it's a third, second, or first generation. What matters is that the wheel bearings in general are a safety critical component. They're responsible for making the vehicle drive safely on the road. And bearings have to be able to handle huge forces, the weight of the vehicle, during acceleration, during braking, and when going around corners.
Yeah.
Look here. Take this model, like this.
Okay.
Imagine there is a wheel here. Can you see what happens when you hit the curb? It's subjected to huge forces.
Oh yeah. I get it. I presume that you want to demonstrate that a wheel bearing like this also has to be replaced at some stage.
Exactly. And hitting the curb is one of the most common reasons why bearings have to be replaced.
And how do I know when the bearing is defective?
Wheel bearing defects don't happen solely because of hitting the curb. There are other factors involved. Bad roads, potholes, etc. And it will probably take a few miles until you notice the noise. But be careful. It doesn't necessarily have to be the wheel bearings. It could be any other component like tires or parts of the chassis.